Here we have a triangle ABC, right angled at A. The measurement of two of its legs, the two of its shorter sides is 3 centimeter and 4 centimeter. Then what will be the hypotenuse? We have to apply the Pythagoras theorem and we see that the hypotenuse is 5 centimeter. What else do we have? On the hypotenuse, we have a semicircle with PQ as its diameter and its center is at the point O. What else do we notice? This semicircle touches the side AC and the side AB. Let us name this point of contact as R and this point of contact as S. Then can you tell me, if I construct these two lines, what sort of a figure will this ROSA be? It is not going to be any ordinary quadrilateral. It is going to be a square. Can you tell me why that is so? Here we already have a 90 degrees. And what do you notice about this AS and AR? They are both tangents to this semicircle, because you can see that there is only one point of contact externally. So AS and AR are both tangents to this semicircle, and OR and OS are both the radii of this semicircle. Then what do we know? At the point of contact, the radius and the tangent meet each other perpendicularly. You have a right angle here, again a radius, a tangent, both of them meet perpendicularly. Out of the 4 angles, 3 of them are 90. Sum of angles of a quadrilateral is 360. 360 minus 270, again you get a 90 degrees here. So what sort of a figure have we got? We have got a rectangle. It is not at a square. What do we know about a rectangle? Its opposite sides are equal. But then OR and OS are both the radii, which means they are equal to one another. AR and AS are both tangents to the semicircle from the same external point A. Then what do we know? The tangents from the same external point are equal to each other. So what we have is a rectangle whose adjacent sides are equal, or in other words, it is a square. Now let me take the radius as R. So here we have an R. All the 4 sides are going to be R, because we just now proved that ROSA is a square. Now if this much is R, what is going to be this measurement? The whole of this side AC is a 3 centimeter. This much is R. Then that means here you have a 3 minus R. Now I have gotten rid of all the unnecessary markings, and let us concentrate on this small beautiful triangle that you see here. Its name is CRO, and can we prove that this CRO, the small triangle that you see here, and the whole triangle, the big triangle that we started with, which is ABC, can we prove that these two are similar? Using AA criterion, can we find two equal angles? Here, one is a common angle C. This common angle, this C, is an angle for both the triangles. So, the place where you see C here, put a C. Then here you have a 90 degrees. Here also at R you have a 90 degrees. So the place where you see R, you put your A. Then there is just one more angle remaining, which is B. So these two triangles are congruent, but then this is how the name is written. It is not ABC, it is CAB. Now, once we have proved that these two triangles are similar, then what follows? The ratio of their corresponding sides are equal to one another. The ratio of these first two sides will be equal to the ratio of the second two sides, and then the third two sides. All the three ratios are going to be equal. And what do we know about the sides of the smaller triangle? CR is 3 minus R. RO is an R. And what about CO? Now where are we going with all of this? What are we trying to find? we need to find the measurement of this segment here, CP. Let me name it X. Then what about PO? It is the radius of the semicircle, which means it is R. So CO is going to be what? It is going to be X plus R. What about the sides of the bigger triangle? CA is 3, AB is 4, CB is 5. Now, when you cross multiply these two ratios, you are going to get the value for the radius of the semicircle. It is going to be 12 by 7 centimeters. So this is 12 by 7 centimeters. And what is this side going to be? It is 3 minus 12 by 7, which is 9 by 7. Let me write that down. Then what do you notice here? The triangle CRO is a right triangle. One of its sides is 9 by 7 and the other side is 12 by 7. And what you need to find is the hypotenuse. So then apply the Pythagoras theorem and what will we get? So that means the whole of CO is 15 by 7. So the whole of CO was 15 by 7. We know that this much was the radius. So this segment whose measure we needed to find, it is 3 by 7. That is all for today. Assalamu alaikum.